Okay, on 8-5, we're going to talk about dilations. On one thing about dilations, you got to know this, okay? Everybody understands that whenever your eyes are dilated, you've gone to the doctor and you're looking to get a prescription, and he puts those drops in your eyes, and you got to walk around with those cool sunglasses all day long because your pupils are the size of saucers and just letting all the light in, okay? Your pupils, they're dilated, okay? But what people don't understand is that your pupils dilate all day long, okay? The actual act of dilation is something going from small to big or big to small. So you got to always think that, don't just get locked in and saying, oh, it's when your pupils get really big. Okay, it's when it can also be when they get really small. Your pupils dilate all day long. From when you walk into a classroom that's dark, walk out into on a sunny day, your pupils are changing size. We're going to look at dilations with shapes. We're going to change the size of these shapes. Okay, now there's a couple things to know is that you got a scale factor, which we talked about. That's how big you're going to multiply this thing by. Sometimes it could be like this, 3 times as big, which means that we would definitely make it bigger. But then it also could be something that we're going to make smaller. So if it was like a half of this, we would make it smaller. Okay, another thing is T is the point of dilation. That means that we use T and we don't move it. But we'll see what is the distance from T to A, and then we'll multiply it times 3 to find our new A. So, what really helps is whenever we have a ruler to do this. So I'm going to kind of challenge myself here because I don't have a ruler. And I know sometimes we get at home and we don't have rulers at home. So what do? You find any straight edge. Okay, any straight edge, you can use this to do our shape here. And what we're going to do here is if T is my center, I'm going to take this straight edge here and I'm going to mark it. And I'm going to say, all right, well, there's T right there. And here's A right there. Okay, and I want to keep this line. So I'm going to draw me a line right through there. And this new A is going to be 3 times as far from T. So I'm going to take this, and notice I marked my straight edge here. That's 1, 2. So now I'm going to mark right here. And then 3. So this is where my new A is going to be. So I'll say that is A prime, my new A. I'm going to repeat this for B and C. Okay, so I'm done with these marks. I'm using this marker here where it rubs off pretty easily. And now I'm going to take T through B. I'm going to draw this line. Okay, I'm going to mark right here. All right, T is right there on my straight edge. B is right there on my straight edge. So there's 1, 2. I'll have to mark there. And then 3. So this point right here, that is my B prime, my new B. Okay, I'm going to repeat the process, but now for C. Once again, I'm going to ignore these marks here. They rub off on my straight edge that I have, and you can use any straight edge. You could even use the calculator edge on our calculators in class. So T to C. Get it all lined up. I'm going to draw my straight edge out. Boom. Mark my edge here. There's T. There's C. That's 1, 2, and 3. There's my new C prime. And so what I have now is I have 3 points right here, and I can connect the dots from B to C. I should have did it in a different color. In fact, I'm going to change my color here after I draw these in so you can see and we'll see all the green lines here. There's my new triangle right there. Got that green line going through it. But what we'll do is we'll take the blue here. So there's our triangle there. There. And there. And that triangle is 3 times as big as this triangle. That's our dilation. All right, so you can see down here, this dilation is an enlargement. We made it bigger, okay? And reductions whenever you have, and it goes smaller. So that's when your scale factor is less than 1. Notice up here, scale factor of 3. That's a number greater than 1. But if we see on the second page here, the scale factor is 4. So we're still going up. If we have a scale factor that is less than 1, meaning that it's 1/2, if it's a fraction, okay, we would go and make it smaller and reduce it down. So from here, as we see this, T is our point of dilation, and now we're going to work off, and it's going to be 4 times as big this way, this way, this way, and this way. So I'll use green to start us off with. Okay, there's my T right there. Now that's 1, 2, 3, 4. And so that would be my new O, which I'll call O prime. I'll repeat this from T to M. Draw it out. Mark my straight edge here. 1, 2, 3, 4. M prime. T to L. One, 2, 3, 4. On the next one, there's 1, 2, 3, 4. That would be my N prime. So there's my new points. Now I'm gonna change my marker color here, and now we'll see that this quadrilateral that we got working up here from these 2 points, then we have these 2 points, and then last, we have a quadrilateral now that is 4 times as big as the original. Okay, on the last one here, determine if the pair of triangles is similar. Remember, if they're similar, they have to have congruent angles and proportional sides. Okay, on A-4, we talked about their shortcuts. We had angle-angle similarity with triangles, side-angle-side, and then side-side-side. And we could just use these shortcuts to prove without having to go through the full thing, because obviously here, if we don't know anything about this angle except that it's congruent to that one. We don't know about the M and the J and the L and the P. Okay, so what do we need to say about this? Okay, you got this 16 and this 11. We have nothing and nothing. But what we do have is we have these tick marks that are here. Okay, those tick marks tell us that this LK is 16 also, just like the tick marks there. And this 11 is going to be the same here. That's 11. So as we look at this, we're going to go side, angle, side. One arc mark, they're congruent, so the angle part matches up. Now, 16 over 11 and 16 over 11. Are these two the same thing? Yes. So this is yes. How do we do it? Well, we did side, angle, side. So now we'll talk about how do we name these. Well, the first one, we'll say it's J, K, L. Now remember the last step on this, very important, M, N, P, that the corresponding points have got to go with the corresponding points for the first one.